Alright, so I'm going to use the sine function for talking about what happens with transformations of this thing, and recognize this does continue to follow this pattern, but I'm thinking mainly about one complete cycle of it. The key features or measurements that I want to think about on this are the top and bottom. Top or max is at 1 and the bottom's at -1. That's also the minimum value of the function. The center line or midline is at 0. Those are going to move with some of these transformations. And then there's your horizontal measurements that are important on this. Begin cycle at 0. End of one complete cycle is at 2 pi. And so the period is the difference between those, how far that is across there. For the base function is 2 pi. We're going to think about how those change if we do transformations of this thing. So now thinking through the different transformations that we had and applying it to this kind of function. Periodic functions is a little different, so we'll explain what's going on. Vertical shift is of course doing something like y equals sine x plus some constant right here. The plus on the outside of the function like that moves the whole graph up or down. You're going to see all of this stuff change, so that leaves all the horizontal stuff the same. Not going to affect the period or anything else if we just shift this up. It moves everything here up or down by a, so the max well, the midline would be up to a. If you, whatever a is, could be positive or negative, but the midline is now at y equals a. The max and min of this thing are going to depend on whether it's stretched out or not, but your amplitude is just 1 for the base function, so this would be a plus 1 and a minus 1. But in general, what you got here is a plus the amplitude and a minus the amplitude. And the amplitude is going to be affected by vertical stretch or compression. So if we have a wave that's oscillating between 12 and 16, the midline would be at 14, the amplitude would be 2 in either direction. So those are easy to figure out from the graph. Also, vertical stretch and compression is going to affect the amplitude. Then that's if I have some number times sine of x. You can use different numbers out there, but if there's a constant multiplied by the sine of x, that's going to affect how much up or down it goes. It leaves the midline alone. It leaves horizontal stuff alone. Still. It leaves the midline alone. If you're only doing a stretch or compression, this is still going to be at y equals 0. But your max and min are going to be up the are going to be up whatever k is. Going to be up at k and minus k. Yeah, as long as k is a positive thing, it's a stretch or compression. So if k is bigger than 1, it's going to stretch it out. And if k is less than 1, it's going to flatten it out. That's why it's stretch or compression. That works with any function. But what that affects here is the amplitude. And the amplitude is whatever k is. If it's a positive number, it's really the absolute value of that. If k was negative, you would have a stretch or compression by this amount and also a reflection of it. Now I want to notice something about the reflection of it. If we do sine of minus x, that's a horizontal reflection. If we do minus sine of x, I don't know why I switched those around, but multiplying by -1 on the outside is a vertical reflection. Multiplying by -1 on the inside is a horizontal reflection. But if you take a function like this and flip it over, it's going to be going down and then up. That's what a negative sign looks like. But if you turn this thing around, it's going to be going down and then up. So the fact is these are equal to each other. This is an odd function. Sine is odd. So doing a vertical reflection is the same as doing a horizontal reflection. It's going to flip it over. Easiest way to think of it is flipping it over vertically. Same kind of reflection. all of this stuff is the same with cosine. This one is different with cosine, so I'm trying to summarize quickly. But if we do the cosine of minus x, if you take a cosine graph and flip it this way, well, cosine kind of does the same thing on both sides. Cosine is an even function. So if I flipped it over vertically, I'd get the exact same graph back. I'd get this thing. So a horizontal reflection has no effect, but a vertical reflection is different. Their negative cosine graphs are gonna have a shape that starts at the bottom of the cycle and comes back to the bottom of the cycle. So you got a negative cosine shape like that. That is different with cosine. Now, horizontal shifts leaves the vertical stuff alone. So your midline and your amplitude and stuff would all stay the same. Horizontal shifts is like doing sine of x plus a. I guess I'll use b here. I'm just trying to use some different letters in there. But sine of x plus b is going to move it b units in one direction or the other. Now, if b is positive, it's going to move to the left, and if b is negative, it's going to move to the right. That's the way horizontal shifts work. That keeps the period the same. But it affects the beginning and end. This would now begin at x equals negative b and end at x equals 2 pi minus b. If I do sine of x plus 1, that's going to shift the whole thing 1 unit to the left. It's going to start at negative 1, and this end would be shifted over 1 also, 2 pi minus 1. So those are useful values, and you want to separate out. The end is not the same as the period. They happen to be the same here because we're starting at 0. But when we move over, we're beginning and ending at different points. The difference between them is still 2 pi. That's still the same period because we just took it and shifted it sideways with them, one direction or the other. Horizontal stretching compression does change the period. So if this is something like sine of mx, then we're looking at when this goes from 2 pi, a complete cycle would be between 0 and 2 pi still, but it's when the input goes between 0 and 2 pi. So if you do a little division right here, you see x is going between 0 and 2 pi over m. The period now is affected by that. The new period is 2 pi divided by whatever that number is. So in the base function, we have sine of 1x, and the period is 2 pi. If I do sine of 2x, it's going to be 2 pi over 2, or just pi, so that's going to shrink it down. So if that number is bigger than 1, it's a compression, and if that number is smaller than 1, it's a stretch. And this is how it affects the period of it. That's the other key piece there, along with this idea that the beginning is shifted over by that. Those are the key relationships to that. Now, if you have combinations of these things, of course, you have to watch the numbers on there and see how it gets moved around. If you have a combination of operations to do, you can move these things around and get any kind of nice wave graph that you want that starts and ends anywhere if you manipulate these transformations the right way. So this is a great way to think about them. It's a lot of good questions on this, but those are the basic facts of how it affects it. You want to think back to your pre-calc way of thinking of it is think back to the base function, and how is the function that you're working with in a problem different from the base function? What are the transformations involved? That's a good way of thinking about these and working through them.